Hi everyone. So we continue on the lesson topic 27. Topic 27 is about related rates, and related rates is like, for example, you have rate of change for one quantity and you want to find rate of change for another one, but both of them respect to time. Okay, so see, for example, we used to have, for example, x squared plus 9 equal y squared. And then I said, okay, find y prime. This was implicit. I told you you don't start from y prime equal. No, that's topic 22. So I told you do derivative of both sides. So you do derivative of that equal derivative of that. But for derivative of left side, you used to do just 2x. For derivative of right side, 2y y prime. What is the reason? Because I do respect to x. So I find the derivative respect to x. So I know y is a function of x, and I do derivative respect to x. So x prime is 1. I don't need to write it. I don't see it anywhere. But y prime is like u prime, so I have to include it because it's a function of x. It's like u. Okay? We used to have this, and now this is different here. Here, both of these are respect to t. X and y, both of them respect to t. Both of them are changing respect to time. For example, I have a spherical like a ball, a snowball, and it's melting. So respect to time, the volume is changing, reducing, and the radius of the ball is also reducing. So I want to know, for example, if the volume is, for example, the rate of change of volume is this, for example, the unit that I have to mention. I want to know how radius is changing. But both of them are changing respect to time. Okay, so maybe I can repeat the same question here. See, I have x squared. If I want to include both of them in the screen. So x squared plus 9 is y squared. It says x prime is 500. So x prime is not 1 because x is respect to t. So here I have x function of t, y function of t. And I have x function of t squared plus 9 is y squared, which is function of t. Both of them function of t. And then I say, okay, find. So if I have x prime, I want to find y prime. So the same, I have to use the same rules for derivative. So I do derivative of both sides. Okay, so first step, I do derivative of both sides. So it's x squared plus 9 equal, so derivative equal y squared derivative. And this is 2x x prime equal 2y y prime. Remember, here both of them are respect to t. So if you have x, you need x prime. If you have y, you need y prime. If you have z, you need z prime. Unless I tell you one of them is constant, then you do 0. One of them doesn't change respect to time, okay? Or I consider constant, so then it will be 0 and I don't need to include. Otherwise, everything needs prime here, okay? So just compare what we have here and what we have here. Here I have both of them respect to time. Okay, so I want to know that. And then it says, what is the value here? When x prime is 500, what is y prime? So then I say, okay, so I have rate of change for x and I want rate of change for y. To do this, I need to do derivative of both sides respect to time. Okay, so that's why I see x prime, y prime. And then I do 2x times 500 equal 2y y prime. Of course, you can cancel 2 and 2. But in order to find y prime, you need 500 x divided by y. You need to know what is x and y. But you want to know what is x and y at that time. So for example, if I say the x prime or rate of x respect to time is changing this, and what is y prime when x is this, when y is that, means at that time. Okay, see here, in order to find y prime, I need to know this. I need to have these two. Okay, so I need more information. And I need to know at that moment that I'm talking about, at that moment. So I want to know at that moment that I have that, okay, what is this? What is dy over dt or y prime? Just in order to make it easy for you, I do x prime, y prime. But you have to know, in this case, both of them are respect to time. And when you look at the question, you understand. Okay, so that's related changes and that's just related rates, sorry. Okay, so here we do this question just step by step. A spherical snowball, which is like a ball, right, is melting in such a way that its volume is decreasing in this rate. Okay, so I can write this way. dv over dt is minus, because it's decreasing, 1, or I don't need to put minus, but I have to remember that the other one is also decreasing. So minus 1 centimeter cubed per minute. Because decreasing, I do minus. Or you can do 1 just plus, but remember the other one is also decreasing. So at what rate is the radius decreasing? And it says what rate is decreasing. Okay, so here I do have this, and I want to know what is dr over dt. What is that? In order to make it easy for you, I say I have v prime and I want to find r prime. But then you tell me, where is the equation? Okay, where is the equation? What should I do here? Okay, the equation is here. So the equation will be given to you, or you can just find it easily with your information. So any information is given, and okay. So find the given rate. Let V be the volume of the snowball and R be radius. Okay, so I did this here. Okay, so I do have yes, so V is volume, then I have dV over dt is this centimeter cubed per minute. Yes, per minute. Okay, even I don't need to put minus, but I have to remember it's decreasing. Okay, and I want to find dr over dt. This is my question now. So I tell you what is the formula, so you have to know it, or the formula will be given to you. Okay, this is the formula. The formula for volume of a sphere is this. Now, step by step, you have to do derivative of both sides. Derivative of both sides, and both of them respect to t. Okay, so in order to make it easy for you, I do v prime. So v prime or dv or dt is 4 over 3 times 3r squared r prime pi. I don't need to be worried about this, and this will be cancelled. So it is 4 pi r squared r prime. This is just a constant number. This one I do have, and this one I'm finding. But how about r squared? I told you I need extra information. I go back to the question. It says when the radius is 5 centimeter. Here I have to be careful about units. Maybe one of them I give meter, one of them centimeter, one of them millimeter, one of them centimeter. I have to convert. Here doesn't matter. One of them is centimeter cube per minute, and here is centimeter. It's okay. I don't need to do any change. It says when the radius is 5 centimeter, means at that time. So I have rate of change for volume, and I want to know rate of change for radius. But at what time? At the time that radius is 5 centimeter, at that time. And I don't know what is the time, okay? So here, I need more information. Look at this. I told you I need to know x, I need to know y. So here I need to know r. Okay? Perfect. So this is here. So here is -1 equal 4 pi 5 squared, because it's given to me from the question, r prime. And r prime is -1 divided by 100 pi. When I see minus, I know it's decreasing. So the answer is 1 divided by 4, 100 pi. Let me see. Yes, okay, so it is, am I right here? Yes, it's 25, and 25 times 400. Yes, so it is 3 point, how many significant? So 3.18, okay, 3.18 times 10 power minus 3. And look at this, even here I see 2 significant digits. This is 2 significant digits. Okay, so I can say here I have 2 significant digits. This is 4 is just a constant number. Pi has many significant digits, so I don't consider. And this is 2 significant digits as well, because it's 5.0. Let me make it more clear. Okay, so I want to find r prime, and then I say, okay, so it's almost 3.2 times 10 power minus 3. Okay, which is 0.0032. Okay, so this is rate of change. So I can write here, I can write rate of change for radius, and I need negative, okay, because it's decreasing. Okay, so rate of change, or I can say the radius is decreasing at the rate of 0.0032. 32 what? I need to say centimeter per minute. Make sure to add sentence. You have to add sentence. You have to add unit. Very important. Here is, this is changing centimeter cubed per minute. But the other one is, so I mean this one. So centimeter cubed per minute for this one. Okay. But the other one, because of r squared, it is just centimeter per minute. Okay. So I can find the answer here. And remember, everything is changing based on time. Otherwise, I say no, it's not. Okay, so here it says sub the information. So here is done. So I did all of them in the last page. Okay, so you have to have the equation. You have to have derivative of both sides. Everything needs prime. You need more information. Go to your question. You have r squared. You need to find r in the question. So in the question, the meaning of the question is, if I have rate of change for volume 1 centimeter cube per minute. At that moment that the radius is 5 centimeter, what is happening for the radius? So I need to substitute 5 there. You need extra information. Okay? And you find the answer. So how about here? A spherical ball is being inflated. So here maybe it's like a balloon, right? So yes, it says balloon, and it's going to be bigger and bigger, so it's increasing. Okay, increasing. So what was the formula? What is that here? Okay, so the formula is here. Yes, 4/3. So I have V equal 4/3 r cubed pi. What do I have? V prime is 8 meter cubed per minute. Diameter. It says diameter. No, it says what is how fast the radius increasing when diameter. So I want to find r prime. R prime I don't know. But I have extra information. It says when diameter is 2 meter, means at that moment. Because the moment and the time is important here. At which moment? So D is that. But I know diameter is 2 radius. Okay, so R is when R is this. Because it says diameter, and diameter is double radius. Okay, so now do it. So anytime you can close, just stop the video and do the question and then check. And maybe you find my mistake and just let me know, please. So V prime is 4/3 3r squared r prime pi. I told you you can cancel this and this. And then r prime is V prime divided by 4r squared pi. Yes? So you have this. You do derivative. So you have all this information. Then you do derivative of both sides. And then you solve for r prime. And now you can find the answer. How? Substitute. Okay, r prime is 8 meter cubed per minute divided by 4 1 squared pi. Okay, and here you have meter inside. So this is meter squared pi. And that's why the unit has meter over minute, because so meter squared and meter squared will be cancelled. That's why you have just meter per minute. So I'm not doing magic, so it will be there when I cancel and when I simplify. Okay, so the answer is 8 divided by 4 pi then. Okay, so it is 8 divided by 4 pi. And the answer is, you can find the answer, 8 divided by bracket 4 pi, which is 0.636. Okay, so 636, let me see, do I have 3? Yeah, okay, 636, which I underline that, check that, it is almost 0.637. Okay, so R is changing, or R is increasing. I can say increasing at the rate of, what's going on here? So R, or radius is increasing at the rate of sorry about that, 0.6367, yeah, meter per minute. Make sure to have the sentence, make sure to have the unit, make sure to check if you don't need to do any conversion for units. Maybe I give centimeter and maybe I want meter. Okay, you have to check those. I'm done with that question. Okay, so here a water tank is built in the shape of vertical cone. Okay, so what's going on here? Here you read the question. A water tank is built in the shape of a vertical cone with a height of 5 meter and a diameter of 6 meter at the top. Okay, water is being pumped in the tank at a rate of this, so means volume is changing. Okay, so look at this. The water tank is built in the shape of vertical cone. Okay, so I have this way. Okay, so maybe I can make it more beautiful. Okay, so this way, right? So vertical cone. The height is from here to here, the height is 5 meter. This is the height. Diameter is 6 meter, so means I have 3 meter here. This is R, because diameter is R multiple 2. Okay, so here you make the question, you just sketch it, you just picture in your head. Water is being pumped in the tank at a rate of this, so means volume prime is 1.6 meter cubed per minute. How do I know? Because I see meter cubed. Okay, and I know that's volume. Volume is changing. Find the rate of which the water level is rising when the water is 2 meter deep. Means it says find the rate, it's rising. So means they want H prime. So it says what is H prime? Okay, when H is this. But here I have R as well. Here I have R as well. What should I do here? So here I have V, I have H, I have R. And I have to have V prime and I have to go to H prime. But what about R? Here you have to somehow remove R. But we can't. We cannot change the question. I read the question. I know, okay, it's a vertical cone. I know what is height. I know what is radius. Water is being pumped, so means volume is changing. And I want to know how, while volume is just while volume is changing, what's happening to the height? How height is increasing in this case. So means I want to find H prime. So this is what I want to find. H prime. I'm looking for this. So it says what is H? This. I need to do something with R. Okay? In these kind of questions that you have, for example, one of them is changing and you want to find the other one, and you have also another variable, you have to have somehow, you have to write one of them based on the other. You have to write one of them based on the other. Okay, so it is, let me see, it is H over R. So what do I have here? Okay, so I want to remove one of them, so I have to write one of them based on the other. I cannot just remove it, no. So I know H over R is 5 over 3. How do I know? I look at these two numbers. Okay, so then I know H is, or I know R is, because I want to keep H, so I have to write R. I know R is 3H over 5, right? So H over R, so R is 3H over 5. And when I write the formula, I can make it easier, and I just substitute. I have to. I don't know anything about R prime. Okay, it didn't say. So it says you have a vertical cone, you have H, you have R, 5 and 3 meter. V prime is changing, so the volume is changing, so that you have V prime, and you want to find H prime. You have also H because you need extra information, but there is nothing about R. Okay, so I have to write R based on H, and I can substitute. So I know H over R is 5 over 3, and both of them should be meter, and it is, both of them, 5 meters, 6 meter, which is divided by 2, 3 meters. Okay, so then I know R is 3H over 5, and I can substitute here. Okay, so right now I need to know what is formula. Volume of the cone. Okay, I need to know that. Okay, so volume of the cone is like a cylinder divided by 3. Okay, so for cylinder I have this guy, and then yes. Okay, so it is pi r squared h divided by 3. Okay, this is volume of that. So what is V prime then? V prime is pi. Can I do that here? I told you, make it easy for yourself. If you want to find prime, then you have to go by a derivative of multiplication. I have to say derivative of this times this, no change, derivative of this times this, no change, so I don't want that. What should I do now? I make it easy for myself. V is pi over 3, 3h over 5, h, right? A squared. I need a squared as well, okay, because it's r squared. Okay, so I read the question. I know three things are changing. Volume is changing, height is changing, radius is changing when when the water is going up. And then I said, okay, I have V prime, I want you to find H prime. But I didn't say anything about R. So I use this equation and I find R and I just substitute. But before I find the derivative, I do substitution because I want to make it easy for myself. Now I simplify. So it is, okay, so it is pi over 3 times 5, yes, 9 h cubed, which is 3 pi h cubed, because I can cancel, divided by 5. This is my V. And perfect, I have V and I have H, and I can find the answer. So V prime is 3 over 5 pi 3h squared h prime. Remember, everything has prime here because it's based on t. Do I have V prime? Yes, 1.6. Okay. So here. So here I can do it step by step. So, but I think I went fast. Okay, it's because it says V has to be expressed as, yes. Okay, so it's done there. Okay, so I can just continue here. It's okay. So what is V prime? V prime is 1.6. So I put 1.6 there. 1.6 equal. So I can write meter cubed per minute. Yes, because I want to keep in my mind what is the unit. So 3 over 5 pi yes, 3 over 5. So I can simplify here. So it is 9 pi over 5 h squared h prime. Okay, so I do 9 pi over 5. What is h? I told you h is 2 meter. Okay, so it's given 2 meter. This is extra information which is given by the question, and then I need to find h prime, and that's what I want to find. Okay, from here you are just solving. Let me see, it must be a squared here, yeah. So it is meter, so I have meter per minute here. Okay, and everything is fine. See, if you multiply meter and meter cubed, it will be meter squared, it will be meter cube, and if you check this and this, they are the same, minute in the denominator. Okay, I have to find h prime. So h prime is 5 times 1.6. So here you are just solving one equation, you are just finding, so it should be that 5 times that divided by 36 pi, because it's 4 squared, 2 squared, sorry, which is 4. Okay, and the answer is 5 times 1.6 divided by bracket 36 pi. Okay, this is 0.0707. So how many significant digits? I think, yeah, here 2. Okay, so that, and I underline that and check that this is almost 0.071. 0.071 meter per minute. So you can write h is, so here it's doing a step by step for every, so for, but I didn't want to confuse you, because I'm just doing in a video and you will lose just the track, so I did everything in one page. Okay, so you can write height. Okay, so we can write height. So the height, so yes, EI, so EIGHT, so the height is increasing, so increasing at the rate of 0.071 meter per minute. Okay, this question was tricky, so you read the question, you picture it, the formula is given, but you see you have 3 variables, but I'm talking about 2 of them, so you can remove one of them. You don't remove it the way that you want, no, you have to do it mathematically logically correct. So you look at the picture, write a relationship between h and r, and then find r, and then just substitute. You substitute here, you first substitute and then find the derivative. Okay, you find the derivative and then just substitute whatever you have to. So here it's let me see, here it's, you substitute there, so let me see, I think I made a mistake here, this must be 25 because it's 3h over 5 squared, right? Okay, so look at that here, I have this function, then I substitute this, yes, this must be 25. Okay, so I need to do 25, right? Okay, so it's pi over 3, 9 over 25 h cubed, so I can cancel, and this is 25, and yes, this is 3 over 25, which is pi 3 h squared h prime, and 9 over 25, okay, so it's 3 h squared, so 3 and 3 you cancel, it's 9 over 25. Just want to make sure it's everything is all right, so yes, that's r, 3h over 5, which is 9 over 25, then it is You cancel 3 and 9, so I can maybe do this, and then I do 3 pi over 25, and then 3 over 25 pi, and then 3h squared. Yes, so that's that. And then I have to do this, right? And then it is 25 times that. Okay, that's pi. It will be a larger number. Okay, so it's 25 times 1.6 divided by bracket 36 times pi. Okay, which is that. Yes. Okay, so that's acceptable. I was thinking it's a very small number and I made a mistake somewhere. So 0.3536. Yes. So you underline that, check that, and the answer is almost 0.354 watt meter per minute. Okay, so you can write the height is changing, is increasing. Okay, the height is increasing. I can do the sentence in just English. So the height is increasing at the rate of 0.354 meter per minute. Okay, so here I had three variables. Based on the question that I see, I find one of them. Based on the other, which is r, I substitute, make it simplified, and then I find just v prime based on h prime based on v prime, I can say. Okay, for this question I do in the next video. Thank you so much. Bye.